Hey there. When you think about the Tibetan Plateau, like serene and majestic probably come to mind, right? Towering mountains.
Right.
But the research paper you sent us, Control of Subduction and Slab Breakoff,
hmm
it kind of paints like a much more explosive picture. It's like a fireworks show of volcanic activity fueled the creation of this incredible landscape.
It's true. The formation of the Tibetan Plateau, it's a hotly debated topic in geology. There's no easy answer.
Right.
But this paper uses, cutting edge techniques to uncover some fascinating clues.
Okay, so most studies, like trying to solve this geological mystery, are limited to, what's happening relatively close to the surface.
Yeah,
This paper goes way deeper.
exactly. Imagine giving the Earth a giant ultrasound.
Wow.
That's kind of what seismic tomography is like.
Okay.
And this study used a global network to analyze almost 3 million seismic readings.
Wow.
They were able to map activity down to almost 3,000 kilometers below the surface. That's almost to the Earth's core.
Wow, that's mind-blowing. So instead of just looking at the top of the mountain, they're looking at its roots, way down deep.
Yeah, and those deep roots have a story to tell. By combining these seismic readings with data from igneous rocks, think solidified magma,
Yeah.
and plate reconstructions, basically, like mapping out where the continents used to be, they've pieced together a timeline of how the plateau formed.
And it all starts with a bang, or rather like multiple bangs, right?
Mhm.
Because this paper argues for not one, but 4 major volcanic phases that shaped the Tibetan Plateau.
That's right. And each phase leaves its own mark on this massive geological puzzle we're trying to solve. What's really cool is that they actually mapped out these distinct phases using a new model, which they call the two-sided breakoff model.
Okay, a two-sided breakoff. So it's not just one tectonic plate diving under another,
Mhm.
like typical subduction zone.
That's what makes this so fascinating. It's much more complex, like a dance, than we originally thought.
Okay, so let's break down the steps of this geological dance. The paper divides the formation of the Tibetan Plateau into 4 major acts, each with its own burst of volcanic activity.
Exactly. And each act is marked by what geologists call anomalies in the seismic data. Basically, zones deep underground where the Earth's structure changes.
Yeah.
Think of them like fingerprints left behind by these ancient events.
I'm intrigued. So Act 1, set the stage for us. What's happening millions of years ago?
Okay, so our first act takes us back 56 to 44 million years ago. Picture intense volcanic activity concentrated in a narrow band across the southern Tibetan Plateau.
Okay.
This is our first clue, and it's a dramatic one.
It sounds like the opening scene of a blockbuster movie. Is this where the two-sided breakoff comes in?
You got it. See, most models of subduction involve one tectonic plate, in this case the oceanic Neo-Tethys plate, sliding, smoothly beneath another, the more stable continental Eurasian plate.
Right.
But this research suggests that something much more chaotic was happening.
Yeah.
It looks like part of the Eurasian plate in a region known as the Kohistan-Ladakh region
Okay.
also started to sink down. So you had pieces breaking off from 2 different directions.
Whoa, a double whammy. No wonder things got so fiery.
Exactly. And this double breakoff created a perfect storm for volcanic activity. You have these massive chunks of Earth's crust sinking down into the mantle, which is incredibly hot. This causes the mantle to churn and rise, loading to a surge in magma that eventually erupts on the surface.
Okay, that makes sense. So 2 plates breaking off instead of 1 equal double the trouble.
Yeah.
What happens in Act 2?
So in Act 2, from 44 to 28 million years ago, the action shifts northwest, forming a new volcanic belt across what's known as the Kontang terrain.
Okay.
And remember those anomalies we talked about? Well, this is where the researchers found something really interesting. 2 distinct zones deep underground that point to not one, but TWO more breakoff events.
So the two-sided breakoff model is back. What plates are breaking off this time?
Exactly. This time, it's the remaining part of that Neo-Tethyan Ocean plate and another piece from that Kohistan-Ladakh region. And the timing of these breakoffs lines up perfectly with the surge in volcanic activity in the Kyangtang terrain. It's like they're directly linked.
Wow, that's pretty convincing evidence. It seems like this two-sided breakoff model is really shaking things up literally. So what happens next in this geological drama?
Well, in Act 3, between 28 and 18 million years ago, things get even more intense.
Even more intense? I could barely handle the suspense.
The volcanic activity we see in the geologic record becomes even more concentrated, this time focused in central Tibet with a few sparks further south.
Okay, so a more focused blast this time.
Yeah.
What did the researchers find deep down that could explain this phase?
This is where it gets really interesting. Deep beneath this region of intense volcanic activity, the researchers found evidence for, you guessed it, another two-sided breakoff. But this time, it wasn't pieces of the Neo-Tethys or the Kohistan Ladakh region breaking off. This time, it was chunks of the much larger Indian and Asian plates themselves.
Whoa. We're talking about massive pieces of the Earth's crust breaking off and sinking into the mantle.
Exactly. Imagine the forces involved in something like that. And just like in the previous acts, the timing of these breakoffs, roughly 30 to 25 million years ago, lines up perfectly with the volcanic activity we see on the surface.
So after all that fiery drama, things must have calmed down, right? Like, we still have the Himalayas rising today, but I don't see volcanoes erupting all over Tibet.
You're right. Things do start to settle down in Act 4 about 18 million years ago, and this, relative calm continues to the present day.
Okay.
But the story doesn't end there.
Oh. What else is happening beneath their feet?
Well, remember how the Indian plate started crashing into the Asian plate millions of years ago?
Right.
That collision is still happening today, but instead of a, dramatic breakoff, we see a different process taking over.
Okay.
What geologists call flat slab subduction.
Okay, I gotta admit, flat slab subduction doesn't sound quite as exciting as, those massive breakoffs. What's the difference?
Imagine trying to slide a thick pancake under, a stack of other pancakes.
Okay.
It's not going to go smoothly, right? That's kind of what's happening here.
Yeah.
The Indian plate is still pushing under the Asian plate, but instead of diving down at a steep angle, it's kind of gotten stuck, and it's dragging horizontally for hundreds of kilometers before it finally sinks down into the mantle.
Okay, so it's more of a slow-motion collision than a sudden break. What does that mean for the Tibetan Plateau?
This stuck plate boundary is what's continuing to push up the Himalayas and the Tibetan Plateau, even, as we speak.
Wow.
And while it's, not as dramatic as those early breakoffs, this flat slab subduction is still causing some volcanic activity, primarily concentrated in northern Tibet.
Wow, so even millions of years later, the after effects of those ancient breakoff events are still, shaping the landscape.
Yeah.
It's incredible to think that something happening so deep underground can have such a massive impact on the surface.
It really is. And this paper does a fantastic job of connecting those dots. It's not just about what happened millions of years ago, but about how those events continue to influence the planet today.
Right.
For example, those breakoff events and volcanic eruptions we talked about, they likely had a huge impact on Earth's climate over millions of years.
All right, volcanoes are notorious for, spewing out gases and particles that can affect climate patterns.
And exactly.
It's like a chain reaction starting deep within the Earth and, rippling out to the atmosphere.
Yeah.
But, figuring out exactly what happened so long ago must be tricky, right?
You're absolutely right. Dating geological events that happened millions of years ago is a huge challenge.
Right.
There's actually a lot of debate about the accuracy of some dating methods, especially when it comes to a place as geologically complex as the Tibetan Plateau.
So how does this paper address those doubts?
Well, what makes this research so compelling is that it doesn't just rely on, deep Earth data. The researchers found a way to correlate those 4 distinct phases of volcanic activity with actual changes in the types of rocks found on the surface.
So they're finding a link between the deep Earth fireworks and the geological record preserved in the rocks themselves.
Exactly. And that's huge because it provides really strong evidence that this two-sided breakoff model isn't just a, cool idea. It actually helps to explain what we see on the surface of the Tibetan Plateau today.
That's incredible. It sounds like this research is a game changer, not just for understanding the Tibetan Plateau, but potentially for other mountain ranges around the world.
Absolutely. This two-sided breakoff model could be the key to unlocking geological mysteries in other parts of the world with, similar tectonic settings. It's exciting to think about what other discoveries might be on the horizon thanks to this new way of looking at the Earth's deep past.
It makes you realize that what we see on the surface is just the tip of the iceberg. Or should I say the tip of the tectonic plate?
Exactly.
Well, this paper really has given us a lot to think about. So the next time you see a picture of those majestic Himalayan peaks, remember, there's a hidden world of fiery drama beneath them, a story that's still unfolding even today. And who knows what other secrets are buried deep within our planet, just waiting to be unearthed. That's it for this deep dive. Thanks for exploring with us.